Hi, everyone. My name is Eric Stolnitz, and I'm a principal developer in the Interactive Visual Media Group of Microsoft Research. Since this is the first year that Mix has offered a track in which Microsoft Research gets to show its stuff, let me tell you a little bit about who we are and what we do. Microsoft Research has over 850 researchers distributed over 8 locations around the world. And we do basic and applied research in all areas of computer science and software engineering. We advance the state of the art so that Microsoft can deliver innovative new products to customers. And we influence just about every product that Microsoft ships today. One of the things we're working on in Microsoft Research is new ways to create immersive content. And I guess I should start by defining what immersive content is. To me, immersive content is content that takes you somewhere else, lets you see the world through someone else's eyes. And to give you some examples, let me show you 4 things that Microsoft Research technology has helped to influence. So you all know that you can stitch together multiple photos into panoramas. You can also stitch together hundreds and hundreds of photos to get a gigapixel panorama. And you can see the kind of detail that that allows. You can zoom in incredibly deeply into this gigapixel panorama to see tons and tons of detail. And you can say the same thing about terapixel maps, like Bing Maps. These are actually stitched together from thousands and thousands of aerial photos and satellite imagery. And so we are able to zoom in to great levels of detail here on Las Vegas. And in fact, you might recognize this location that we're zooming into now. Here's another example of immersive content. This is Photosynth, and it also combines many, many images, but in a different way. It analyzes the images to discover their 3D relationships and allows you then to rotate around objects and to move left and right and forward and back to investigate the 3D space. So here we're going to move inside this fortified tower and take a look at what's inside. Now we'll spin around and sort of see a panorama view, but inside the tower. It gives you a good overall sense of the 3D space, both inside and out. Let me move on to the next example. The next one is Worldwide Telescope, which you might have seen demonstrated by Jonathan Fay at yesterday's keynote. He was using a Kinect to control it. Here I'm using a mouse to look at the night sky and all the constellations, getting some information about stars, and then panning across the night sky to find an interesting location where I'm going to zoom in and see Hubble Space Telescope imagery of the Ring Nebula. Now, with Worldwide Telescope, you can explore not just the night sky as it appears from the Earth, but also get outside of our solar system and see the planets as they orbit around the sun, find out more information about those, and not just the solar system, but also all the known galaxies in the universe as we've observed it so far. So those are just 4 examples of immersive content types that Microsoft Research has had a part in. But these are 4 examples that you can get your hands on today, and I encourage you to go out on the web and search for them and make use of them. But what I'm here to talk about today is something new from Microsoft Research. This is prototype work that we're developing currently. So it's not available to you yet, but we hope to give you a good glimpse of it so you can see where we're headed. The idea of this technology, which we're calling spin movies for now, is that we want to enable users to be able to capture 3D objects using nothing more than an ordinary camera. Now, let me present the motivation for this project. Really, today, capturing a 3D object, at least in a photorealistic model, is really hard because it can be expensive if you have to use custom lighting equipment or laser scanners. It can be time-consuming if you're manually entering a whole lot of points from a 3D model. Or it can be difficult if you have to learn challenging 3D software. By contrast, we'd like to make the creation of photorealistic 3D models really inexpensive and fast and easy. And we propose to do that by using just an ordinary camera, whether it's your point-and-shoot camera, a video camera, or your cell phone. Before I describe how we do it, let me just give you a demo of some of the kinds of results we're already getting from our research prototype. So I'll switch over to a desktop application that's running using DirectX. And here I'm showing an example of a guitar in its case. We captured 14 photos simply by walking around the guitar and taking pictures. And this is the kind of result we're getting. So I hope you'll agree with me that this is a lot more fluid and a lot more expressive than just looking at 14 photos. And it gives you a sense of the shape of the object and its surrounding environment. Let me show you some more examples. So here's a car model that we created just by walking around the car, taking 40 photographs. And once again, I can spin around. This time we walked all the way around, so I can do a full 360 spin. Again, more fluid than just looking at photographs. Another example, say a house. You can imagine looking at a car, as I just showed, would help you sell a used car. Looking at a house in this way might be a good way for a real estate agent to show prospective clients a house without taking them to the site. So here we go. And again, we went all the way around, so I can spin it freely. Okay, just another example to show you that this isn't all canned demos. I actually did go down the strip a couple days ago and took some shots at Harrah's Casino. This is going to be 20 photos of this statue inside Harrah's, and just a half circle here of photos around the object gives me a good sense of the depth. In fact, when we zoom in, and you can see the money spilling out of the suitcase and the dog in front of the statue. Okay. Oh, what the hell? Why not one more? So Elvis was here a couple of days ago. I don't know if you guys saw him, but in case you didn't, here he is. He was nice enough to stand still while I took these, 16 photos of him. And so not just objects, but also people. All right. Back to the presentation. Thanks. So by now you might be wondering, how does this work? How are we doing this with just photos? So there are 3 stages to our process. The first is obviously capturing, and as I said, that's happening with an ordinary camera of any type. The second stage is processing, and that goes on in the cloud on a server, and I'll get into more details on that. And the final stage is rendering, and that can be on the desktop, as I've shown, or on the phone. So a little more about capturing. Suppose I want to capture this guitar. The first thing I do is I point my camera at it and take a picture, right? Then I move over, I point my camera again, and I take another picture. And so on, and so on. As I move around in a rough circular arc, I just keep taking pictures. Sounds simple, right? You might be asking, how many photos do I need to take? Well, 3, 4, 5 is enough to get started, but if you want to show an object from one side, maybe 10 or 15 is a good number. If you want to go all the way around, we typically take 30 or 40 images. So it works out to roughly every 5 or 10 degrees to get a good result, and then our renderer can fill in the in-between angles that you didn't shoot. I want to point out that we can be rather sloppy when shooting these photos. So as I've tried to indicate on the slide, we're not moving along a perfect arc. We can move in or out or up or down. We don't need to use a tripod or a rail to align the camera, nothing fancy like that. Just hand hold the camera, point it at the object, and shoot. It's really easy. So the next thing that happens with the photos is we process them, and as I said, that goes on in the cloud on a server. It consists of these 5 steps that I'll go over in a little more detail, but first I want to mention that it only takes about a minute for a dozen photos, maybe 3 or 4 minutes to do a full 360. So it's relatively inexpensive, and we see opportunities for improving that performance as we parallelize the algorithms and move it to Azure. So a little more detail about these steps. The first step involves feature matching, where we're examining the images and looking for recognizable features that we can match between images. So, for example, the hole in the middle of the guitar on the left image matches with the hole in the middle of the guitar on the right image. Once we've done feature matching, we can use that information to estimate the 3D positions and orientations of the cameras, shown here as red pyramids. And that information is processed in the same way that Photosynth processes the images. So feature matching and camera pose estimation comes from the Photosynth pipeline. But we do a few new things in addition. So first of all, you'll notice that these little red pyramids representing the camera positions are not in a perfect arc, as I said. So we're going to smooth that out by doing camera path stabilization to come up with an arc that approximates those 3D positions in space with a smoother arc, and that's what's going to give us this fluid motion. The next step is computing depth from stereo. Now that's a computer vision algorithm that compares images, adjacent images, and determines how pixels in the images are moving, and from that information can estimate the depth of objects in the scene. So far away objects are moving at one speed, closer objects are moving at a different speed, and that information along with the estimated camera positions is enough to give us depth information. So here depth is represented as a grayscale image from dark to light as we go farther away. Once we have that depth information, the final step is to approximate it using planes, and that will give us a coarser representation, or sorry, a smaller representation that we can then send back to the client to render things. So we find places where the depths are similar and aligned with a plane, and we separate those out. And here we've colored different planes using different colors. Once we have that information, the smoothed out camera path and this approximated depth with planes, we can send that back to the client for rendering. So the next stage, the rendering stage, we use an image-based rendering algorithm. That means we're using only pixels from the original images, which is what preserves the photorealistic nature, what makes it look so real when we're done. Every pixel is coming from one of the photos that I took. In order to present you with a new view in between those angles where you took the pictures, we're blending between the nearest two views. So we render the scene from one existing camera angle and another existing camera angle and blend between those. And this is a simple enough algorithm that we can run it just about anywhere that has some hardware-accelerated 3D graphics. So as I've shown you, it can run on desktop using DirectX or OpenGL. It can also run in the web using the new features of Silverlight 5 or WebGL. And it can run on the phone using XNA on Windows Phone or OpenGL on other platforms. So to demonstrate that, let me switch over to the phone and show you a demo. Okay, so this is Windows Phone 7 running XNA. I wrote the code in C#. And we're looking at the same guitar that I showed previously. And I can spin it nice and fluidly. And I can pinch to zoom. Okay. Let's take a look at another example. So this one's nice. As you see it, the image is loading initially. You can see how jerky it is and how sloppy we were when we walked around taking the initial photos. Once those photos come in along with the 3D depth information, I'm able to move it much more fluidly. Okay. And one final example. As I said, we can shoot pictures of people. This is just 7 images of Sudipta Sinha, who wrote the back-end server-side processing, so I want to thank him for his collaboration. And you can see he's serious and smiling, serious and smiling. I also want to thank Johannes Kopp for working with us on the rendering. Okay, let's switch back to the slides. Okay, one thing I wanted to mention is you've seen it working with photos, but you might be wondering why we don't just do a flipbook animation of the photos. And I hope you realize that if I just flipped through the photos, it would be really jerky, and also it wouldn't be stabilized. So those are 2 advantages that we're getting over just using photos. But you might be asking, why not just use a video and scrub through a video? First of all, as you've seen, it runs on the phone. If you wanted to get a video of that density, that much information down to the phone, you'd be using up a lot of bandwidth to get that down there. Second of all, most videos wouldn't allow you to scrub interactively nearly so smoothly and get that fluid motion that we're getting. So I've talked a lot about spin movies. That's just one kind of immersive content. You also saw several others at the beginning of the talk. But there are plenty of other types of rich interactive content and immersive media. And one of the other problems that we're approaching in Microsoft Research is how to combine those seamlessly to create new experiences. And here to talk to you about that aspect of our work is Joseph.
Hello. Thanks, Eric. Thanks, all of you. This is the last session for Mix, so I hope you had a great Mix. I am Joseph Joy. I'm a principal architect with Microsoft Research India. I'm part of the advanced development group over there. So this project is a collaboration with my group and Eric's group. As Eric was saying, there are these wonderful visualization experiences out there. There's more coming every year. You hear about new things that are more and more immersive and so on. But from my perspective, they are really islands of interactivity. You go to a particular site or a page, in a site, and you work with one, and then you move to somewhere else and work with the other, and so forth. And what we are really interested in is, and we see an enormous potential in combining these two, all these things into something that's very holistic. And this thing is extremely hard to do today. You can, if you have a particular vision and architecture in mind, do a lot of custom coding and build a kind of one-off application. But we are really after something much more ambitious. So the goal of our project, which is called Rich Interactive Narratives, or RIN, is to make it possible to make extremely compelling experiences that kind of can tap into these sorts of rich interaction that you've seen that Eric has talked about, and to make it far easier to do these things than build a lot of custom coding that is the situation today. Now, our approach is to merge, so our philosophy is to merge two worlds that have today stayed mostly apart. The first one is the world of the kinds of visualizations that we're telling you about. They're extremely good for exploring things. You can explore, and especially if the data that you're exploring is complex, it certainly has a lot of value, and that's the way, in fact, these things are used today. The second is the world of the narrative, and of course, that's best exemplified by movies. It's really hard to think of something that's as engaging and compelling as a good movie. You really get sucked into it. But even when you think about things like good textbooks and documentaries and so forth, it's not just the emotional aspect, but having a very directed path is very effective for conveying information. Now, of course, what we would like to do is merge these two worlds. Now, we are not the first to do this. There are other examples of this. In fact, I'd like to call out the TOR feature in Worldwide Telescope as an excellent example. But we are somewhat ambitious, and we would like to do this really for any kind of experience, present or future. And to do this not as a one-off application, but kind of thinking of it as a data model and so forth. So what I'm going to do to kind of give you a sense of where we are today with this, what's our philosophy and the technology and so forth, is to start by giving sampling of some experiences we built using our technology. So one thing I want to tell you about these demos is that I wasn't sure about the internet connectivity that I would have here. So I pre-rendered them. I kind of ran through these demos on my desktop and rendered them using Expression Encoder. And that's what I'm going to be showing you, but I'll be talking to it. And it's a little bit jerkier than I would have liked in ideal circumstances. So the first example here is a narrative built by Eric about his travels in Argentina and Bolivia. And I'm just going to let it run, and then I'll interrupt. So here we go. We are kind of
For the next part of our trip, we took a bus to the northern border of Argentina. We crossed into Bolivia and headed for the small town of Tupiza. This was the starting point for a 4-day excursion into the extremely remote southwest corner of Bolivia. Here's some aerial photography showing the spectacular volcanic landscape in this area. To travel here, we had to take a jeep with enough gas, food, and water to last several days.
Now I've paused the narrative. So this plays out kind of like a nice documentary movie, perhaps. You got immersive diving into satellite imagery, a soundtrack, and so on. But you can do a lot more with this experience. And to show that, I'm going to actually go back and play a certain part of the video again, or rather the narrative again.
Here's some aerial photography showing the spectacular volcanic landscape in this area.
So I've interrupted this narrative, and I'm starting to interact with it. And this was not a pre-rendered instance of of maps that you saw, but this is the actual Bing maps. And I, as a viewer, can roam around and explore this area to my heart's content. Here I'm sort of navigating just like you would. In fact, this is Bing Maps. If I wanted to see more context, I'm zooming out here and switching the view to add labels and so forth, which is obviously something that you couldn't possibly do if you were just watching a video. So here we are. You notice the Atacama Desert over there, off to the kind of northwest, and then right north of us is this massive salt flats that the narrative actually talks about later. And whenever you're done exploring, you get right back to the timeline.
To travel here, we had to take a jeep with enough gas, food, and water to last several days. In this part of the world, there are more llamas than people. But the few people we met were very friendly and welcoming.
So I'm going to skip to a later part of the narrative.
Our next stop was a place called the Stone Tree. It's actually rock left behind after the desert wind eroded everything around it. But by far the most amazing place we saw was the Salar de Uyuni. It's the largest salt flat on Earth. It covers more than 4,000 square miles in area, and it takes a whole day just to drive across it.
So I pause the narrative, and what you're seeing here is, in fact, a 360-degree panorama hosted on Photosynth.net. It's all coming off the network. And as a user, you can pause and explore just like you did with the maps, look at some interesting things. There's a lot of interesting things like this mirage-like effect there. And you can wander around and look at other things again. You've paused in the narrative here. And for example, there's these interesting hexagonal formations that you can see about salt crystals. And so on and so forth. Yeah, and then when you feel like you're done exploring, as you did earlier, you basically resume the narrative.
In the middle, all you can see is salt in every direction. It can have strange effects on you. I don't know if Beatrice got taller or if I got smaller. Out in the middle of this sea of salt, there's an island of rock that was once the top of a volcano.
All right, I've paused again, and this is yet another panorama. Now, think for a bit what it would take for you using today's technology to try and make something like this. Okay, we are bringing in different kinds of visualization tools, photosynth-based panoramas, media, audio, and so forth. So you'd have to obviously script.
And oldest cactus plants in the world.
Add in audio, synchronize
After
your audio.
4 days in the outback of Bolivia,
Here
we left the
around,
salt
so if you want to jump
spectacular
around as a
volcanic
user, you've got to
landscape
bring in
in
the
this area.
appropriate media and script it all along, pause for interactivity, and so forth. So basically, I'm sure you realize that this is highly, highly complex. Now, just to make the point that this is not something that's hard-coded to the set of experiences that I've shown you in this narrative, I'll now give you a snippet of another narrative, which is about an entirely different topic. And that's about chess. So this is an annotated chess game.
Hi, I'm Kapil Chandran. I'm a 7th grader from Wilton, Connecticut. I'm 12 years old, and I've been playing chess since I was 6. My current FIDE rating is a bit over 2,000. I think chess is a fascinating game, and after watching this segment, I hope you feel the same way. This is a game between the American, Paul Morphy, who will be taking the white pieces, and the team of the German Duke Karl with the French Count Isouard.
Okay, I've paused this, and what you're seeing over here is an actual semantic chessboard. It's not just an image of a chessboard. And you can actually play pieces yourself and so forth. And it's sort of designed around being able to talk about annotated chess games, so you can jump to later points in the game. It's like semantically a chessboard. And in fact, I'm just going to let it play for a bit to see this part of the analysis.
Black is under a lot of pressure and decides to trade off some pieces.
But if you, as the user, want to get excited and you want to try something yourself, you can take over. And in fact, this particular experience has a built-in chess engine. So if you turn it on, you can sort of try your variant with having the chess engine as an adversary. So here I'm going to play a few pieces here. We kind of go at each other for a bit. And then when we feel that we want to get back to the original, this is a very famous chess game, all we do is click play, and it'll switch back to that thing and keep going.
White finds a nice queen sacrifice, culminating in checkmate. In the end, black has a queen and a knight for just 2 pawns. However, his rook and bishop are sitting at home, watching TV.
So you've seen another, which maybe at the surface it looks completely different. Okay, there's some similarity in the sense that you use a narration and you can interact. But it's bringing in an entirely different interactive experience. So we have built several of these. And we have some of these on a Azure-hosted site called digitalnarratives.net. They cover a fairly broad set of subjects. And these narratives are actually data, and there's only a single player that's playing all of them. So as you watch them, even though they may be wildly different, they're actually being played by the same instance of a player. And what about authoring, you might be asking? There was no software that had to be written to build each instance of the narrative. They were all composed using a GUI tool. So before I dive into the details of how we went about these narratives, I want to kind of take a step back and looking at, how do we approach this problem, if you want to call it a problem or opportunity, of trying to combine the world of interactive visualization with this sort of cinematic narrative. So basically, our approach is to take kind of a step back and look at, first of all, what is this thing we're calling a rich interactive narrative? What is it as a kind of semantic entity? When you drill down to the pieces, what makes it up, what is the relationship, and how you might represent it. It's kind of analogous to how you might think about defining HTML, let's say, on the document object model. And that is what we have done. That's a fair amount of effort, is sort of having the semantic definition of these things. Of course, just walking around waving a specification is not going to do anybody much good. So you need to have tools that can create content and tools that can render and play this kind of content. But really, the most general representation of the problem is that you've got a data model with some semantics, and you've got like an ecosystem of tools and services that manipulate it and consume it and so forth. That's sort of the general approach that we've taken. Now, the RIN data model, I will get to it later on, but it's a kind of abstract and dry thing. So what I'm going to do next is switch over and give you a demo of our authoring tool. Here's a screenshot of our authoring tool. A couple of things I want to tell you about this. It is a fairly functional tool, and it was, in fact, used to create the narratives on digitalheritage.net. But it is a research prototype. This is, after all, a research project. So it's not that we have some release plan or something for this. The second thing is, as I said before, this is not the authoring tool, but an instance of the kind of tools and services that could create this content we are calling, or this new media type, if you will, we're calling a rich interactive narrative. All right, so I will be building a small, couple of small narratives right here, and this is a live demo. And I will be using the network, so let's see how this goes. This is the tool, and as you can see, it's got, it's very similar at first glance, maybe even second glance, to a movie-making tool. You've got assets that you can pull in. You can drag them onto a timeline over here, and then you can preview things in a preview window. But the point of departure is the assets that you can bring in are not these sort of passive assets, but they are these full-fledged interactive experiences, such as maps and so forth. And what I'm dragging here onto the timeline is a close to 1 billion pixel image. It's a DeepSoon image hosted on Azure, and it's being manipulated here just like an ordinary asset, just like you would a picture or something. Let's take a look at this. It may take some time to load, depending on the network. So this image is of a fascinating machine that's called the Difference Engine number 2 by Charles Babbage. Let's hope it comes up fairly soon. I do have a backup plan, which is like a smaller version that's on my machine. Give it a few more seconds over here. So let me kill the preview and go back to the tool itself. And we can also view the same image by clicking on this thing we're calling the part editor. So that's what I'm doing right now. So while it's coming up, let me tell you a bit more about the image and the technology that we used to build that image. So this image is of something called the difference engine, and it was computed. It was basically designed over 100 years ago. I think this is just taking way too long to converge. Oh, there it is, just as I said that. So I'm going to drag this up. And there are only 2 of these in existence right now. This particular one is located at the Computer History Museum in Mountain View on loan from Nathan Myhrvold. And the other one is at the Science Museum in London. And both of them were built under the guidance of Doron Swade at the London Science Museum. And it actually computes high. What it is a completely mechanical calculator of high-order polynomials. And you really do need this kind of gigapixel resolution to really get into the full complexity of this machine. I've zoomed in all the way over here and kind of giving you a sense of these different pieces. And so this is the example of a piece of interactive media that I'm bringing into that authoring timeline. So let me close that. So what we're going to do as part of this demo is build a little narrative that essentially walks through some interesting features of this engine. So this is that same thing called the path editor that I'm bringing up. And I will be walking through the process of kind of visiting segments of it little by little. I guess it's taking its own time to play once again. There we are. All right, so I'm going to essentially explore this world and capture what we call semantic keyframes that define what is it that you're looking at that time. So we'll start by capturing, let's say, kind of a nice wide-angle shot of this thing. Zoom in on these things called figure wheel columns. These are the actual columns that keep track of the calculations. And then I'm going to zoom in some more to take a look at the real detail of these things called figure wheels. And let's capture that. Let's zoom out again a bit for a kind of a mid shot. And then we'll go to another remarkable part of this device, which is this automated printing system. So the results of your high-order polynomials are fed into this printing system that creates typeset faces. So let's get a nice detailed shot over here. Now, what I've been doing so far is not capturing screenshots, but rather the logical state of the view into this experience. So you can jump around and let's add a little bit of pauses at each point. You can adjust the speeds and so forth. And when we are done, we have the whole timeline here. When you play it, you'll see it kind of going through its paces. So there's your initial shot. That's the detailed shot and so forth. And this is not the pre-rendered image, obviously. So at any point, I can take over and interact with it. It's the hallmark of a narrative. And you can compose with other things, like if you want to bring in some appropriate music, just add it to the timeline. You need to stop over there, and it'll stop playing. And similarly, you can add usual kinds of things you would expect in composing kind of a linear narrative, text, and so forth. You can highlight regions of this image and so forth. So I won't go into those details over here. So the experience of authoring using this tool is to drag in these assets. These assets can be these interactive kinds of things. You can compose with more traditional media and sequence the whole thing. I'm going to show you another example that brings in a different kind of visualization experience. So let's start and kind of tell a slightly contrived story that talks about the plight of endangered species, and in particular frogs. So we are switching gears from the difference engine and computing polynomials to looking at the plight of frogs. So what I'm going to drag in here is another example of visualization is what's called Pivot. So some of you might be aware of the Pivot viewer originally from Live Labs. Let me click on it, and you'll take a look. So this Pivot viewer is excellent for data visualization. What it's great at is if you have thousands of objects They have some visual component to them, and you can slice and dice them and filter them and so forth. And what we'll be using to make this narrative is talk about, using that collection, we're going to get some insights about sort of demonstrating that frogs and amphibians are particularly threatened, and that and then we home in on a particular frog and so on. I have a particular storyline in mind. So while we wait for it to load, this is kind of the visual of the pivot control slowly loading. You can see I definitely made a good call in pre-rendering my initial thing to video because the network is behaving a bit spotty. All right, so what you're seeing here is sort of a bird's eye view of about 1,000 species that are endangered according to the red book. And if I zoom in, you can see details in here. They're all the way down to the individuals. It's bringing everything here over the network, so you can look at details and so forth. But you can do a lot more. Again, what I'm demonstrating is a tool which is an example of a data visualization tool. It's out there, and then we'll see how we can bring it in to tell our stories. So you could do things like sort it by various categories and so forth. If I sort it, it should get into a sort status in a bit. There it is. The different categories. You can switch your axis of sorting. You can filter it and so forth. Anyway, so this is the tool, and what I'm going to make the case for as part of my story is talking about kind of the relative endangeredness of amphibians. So let's first pick the sort order here to include amphibians, and it should change. And I'm going to capture that state. Again, it's not a screenshot. That kind of sets the baseline for my story, saying, hey, look at the list of species organized by class. And of course, you'll notice that there are amphibians. The number of amphibians is quite a bit less, maybe a fourth less than, let's say, birds. But that doesn't tell the full story, and which leads me to the next part, which is that if I look at the critically, and so I'm filtering it out here, looking at just the critically endangered species, and you'll see that they're actually amongst that kind of more refined but more adversely affected subpopulation, they are actually a lot more. So the relative percentage of critically endangered species is much more. And this is the kind of insight, in fact, that a tool like Pivot is very good for. But think about how it's used today. At least most people will pretty much just bind the pivot control to some data and leave it out there, and anybody can come and play around with it, and it's useful. But suppose I had got this kind of insight, and I wanted to communicate it to somebody else. How would I do that? I maybe write up an email or pre-render a video, but you wouldn't be able to interact with the video. So anyway, we've established that these guys are not doing so great. What I'm going to do is, again, in this slightly contrived example, home in on a particular species of frog, which is among these critically endangered species. Now this frog is located only in a small part of the Earth. It's basically in Crete and a small island in Greece. And in fact, that's listed here somewhere if I go down the path. Oh, there it is. It's found in Greece. And I happen to know, well, it's Carpathos, so I happen to know that it's the Carpathos island. So anyway, I'll capture this state. Let's adjust the timings. That's what I'm doing over here. Mistaken. And it's just waiting for it to settle down, I suppose. Let's see. There we are. So far I have essentially created that part, which is talking about the plight of these frogs. What I'm going to do next is basically bring in maps, because to explain, what I'm sort of trying to say is that you can bring in these different kinds of visualization experiences where they're needed. So what I'm going to do is basically use this wonderful map experience that has been brought into our system and continue the story that I'm trying to tell. And let's again wait for it to load up. And what I'll be doing is finding the location on the map, Carpathos Island, and then essentially zooming in there, switching map styles and so forth as part of the example. So it's buffering. Here is the map, and let's find the island. There it is. So I'll pick that as my starting point. Let's see. And in fact, I could stop there, but I would say it's just to show you that you can actually craft these paths in maps as well. Let's bring this whole story back to where we are right now in Las Vegas. So let's just add, I guess a little path bringing us back from this example to mix. So let me search. Well, before I do that, I guess what I'm going to do is change the style to be a little bit more satellite imagey. So we do that. So we start with that. Switch the styles to this, and it'll show up eventually. And then I'm going to add another component in a bit. So yeah. So let me now add our final destination and this little path through maps, which is our wonderful site of the resort. There we are. So switch the map style again to aerial and zoom in nice and close. Here we are. So I've kind of zoomed in, fairly close to where we are today. So we should be all set. Yeah, that's a good point, Eric. It pointed out that I need to move the intermediate point over here. And in fact, another thing I want to do is just zoom out a bit to kind of frame Asia. I wanted to do that as well. So we'll capture that. So let's see. We start with the island view with labels. It'll show up if I play. There it is. We switch to satellite view, zoom out a bit, and then finally jump all the way down to, there we go. All right, so we kind of got that in place. And just to add a little bit more pizzazz, what I'm going to do is bring in some nice music. I wanted to stop at the end as well and just, pardon my mumblings, but basically what I'm doing is setting the timing so that it doesn't just all fly by really quickly. Waiting for it to load. And then when we're all done with this, I'll play the whole thing from start to finish, and hopefully it'll show you, and then I'll show you the interactivity as we come and so on. There we are. Let's make this a little bit longer. Increase the timing of this one a little bit, decrease the timing of this a bit. Okay, here we are. So let's see how this looks in the preview, and then we'll see how it looks full screen. So normally you would add either some labels or a text narrative, maybe some frog chirping and so on for good effect. Takes a bit of time. Spending all its time loading. Yeah, this is definitely the challenge of bringing in content over the internet. So yeah, what I'm basically doing here is waiting for it to catch up with things, and it's sort of acting a bit sluggish. So let's go back to the beginning and give it a second chance. There we go. It should update in a bit. Again, this is why we call these things research prototypes. But actually, the code is very stable. It's just, I think it's really getting screwed up by the network bandwidth over here. You can see it's moving and doing its thing. So let's see how it does now. So it should be playing. is acting a bit flaky today. Give it a second or two, and oh well, demoitis. So I can try loading that once again. We'll give it one more shot, and then we'll just get back onto the main line of the narrative. So we had what we were looking at was the Rin Studio, which is our prototype application tool. And then we'll bring up that same application, or maybe we can, in fact, what I'll do is look at a previously constructed narrative. So let's just look at, in fact, what I'm going to do now is open up Eric's Argentina and Bolivia narrative, so you can see what that looks like. And let's hope that this comes up fairly soon. So yeah, every single one of the narratives that we were showing on digitalnarratives.net were composed using this tool. And in fact, we do have a more finished version of the endangered species one as well. You could go and take a look at the kind of thing I was trying to build, but running into problems clearly. And likewise, the Argentina and Bolivia and the chess one and so on. These are all examples that were built using this tool. All right, it's doing its thing. There it is. So this, you can see, once again, you got all kinds of assets on this, on the timeline. Some of these pictures should be familiar to you now because that was part of the initial demo. And you can jump around and view different parts of it. It'll bring in that appropriate. These are all deep zoom images hosted on zoom.it, and overlaid with different kinds of audio and video tracks and so on and so forth. And so what this application generates is not, what it generates is an instance of that data model I was telling you about. So it's not code that it generates, but rather data represented in the form I was describing to you. So I'm going to switch over next to talking about what happens to that data that you create. What is the player, how does the player take this data, and what does it do with it? So let's get back to the presentation. And once again, as I've mentioned to you, you can take a look at the narratives hosted on digitalnarratives.net and play around for yourself. Hopefully, you'll have better luck with the network. So the output is an instance of a rich interactive narrative. And I'm now going to talk about what happens in the player, an instance of what's a typical reference architecture for a player. Well, on the left-hand side over here, you'll see the narratives, such as the ones we've created. That whole thing is interpreted by a core module that essentially takes that and orchestrates all these different experience streams, bringing them at the right time and sequence and so forth. And to actually visualize the appropriate experiences, it dynamically brings in these plugins that are there on the right-hand side. So these plugins are the most important unit of extensibility for our platform. We call them an experience stream provider. Each of them is responsible for a particular kind of experience, such as mapping and so forth. And how are these things actually built? Well, typically they are built by starting with some existing third-party control. For example, the Bing Silverlight Maps control if you are building for the Silverlight platform. So that exists already. The Silverlight control for Pivot is another example. You then have to write just once some code that essentially wraps that control into the form that our player understands. And that can be a varying amount of difficulty depending on the nature of the complexity of the visualization that you're trying to bring in. It took about a day or two to bring in Pivot and the chess control to give you a sense of the complexity of something like that, whereas Maps, which has a lot more power, including being able to put in polygonal surfaces and so forth. That took, maybe a week or two or maybe a little bit more to do that. So once you do these things, they are brought into the system. They all export an interface which is remarkably simple and which has been remarkably stable. So this is a research project, and we were kind of defining semantics as we went along, and we kept adding new experiences. But this interface has stayed remarkably stable, and that's because it's also fairly simple. And I'm going to show you a C# representation of it here, just to give you a little bit more concrete sense of what does it really contain. And at the top are basically loading and binding to data, and then you essentially, the role of these experience streams is to go from state to state. That's all the player really cares, is go to this state and then go to the state and kind of support a logical timeline. And the authoring tool that I was showing you or trying to show you does not need to be recompiled for each new experience. If you have your own custom visualization, let's say a financial data visualization that you want to bring in, basically using dynamic linking and MEF and so forth, it gets discovered and brought into the tool. So it has to essentially expose a very simple interface that's essentially get me a logical state and take your logical state. So there you have it. You got what I've shown you is so far is sort of the overall look of the player. I'm not going to jump into some details of this data model I've been talking about so much. There's not enough time to get into the details of everything, and it is kind of abstract and fairly dry. But essentially, at the topmost level, think of a narrative as made up of things called segments. These are kind of chunks, or the basic blocks of a narrative. You can link them up any which way depending on what you want to achieve, a linear narrative, or you want to allow branching and so forth. But really, the heart of the content lives in a segment, which you can think of as the analogous to a web page. That sort of contains the meat of the content. And the authoring tool, what we were building there was one segment. So you can make these segments and string them up. A segment obviously has all the information. I'm going to drill down into a segment and talk about the various components of the segment. So the first one is something we call an experience stream. And each experience stream, the way to think of it is it encapsulates a kind of a logical path through an arbitrary world. So let me make that a little bit more concrete. So an experience stream for a map would be defining a logical path or a flight through, essentially a map. So it would have things like coordinates and latitudes and longitudes and so forth. An experience stream for pivot, on the other hand, would be a kind of sequence of logical states as you walk through the pivot control. Which facets are you pivoting off, what filter modes, and so forth. So that whole thing is encapsulated. Again, we're talking about data, not code here, in this thing called an experience stream. Then obviously, these things come and go, and they share screen real estate and so forth. So the orchestration information is encaptured in a screenplay. This is, very roughly speaking, it is kind of a screenplay for a movie or the director's conductor score and so forth. It tells when do these guys come, when do they go, how do the layout change over time, stuff like that. And then finally, there's a lot of media that's referenced, and an important detail in this model is a kind of a structured way to reference external media and so forth. And I'm going to drill down just a bit into one of these, which is the experience stream. And at a high level, it contains two kinds of data. One is the data that's kind of shown on the left is the data bindings. How do you take this experience and bind it to data? So for the pivot control, for example, it is, well, where's my pivot collection? But for more complex visualizations, it might contain a lot of other information. For maps, it may be what layers do I want? Do I have additional polygons and push pins and so on? So all of that stuff is what we call data bindings, and they help define the world. And then on the right is the thing which defines the evolution of that world. So simply, it's a path through that world, but more sort of generally, it's how does that world evolve to tell your story as a function of time. So we call that a trajectory. And it contains different things, but really at the heart is the sequence of these logical keyframes. And it would get even more dry, so I'm just going to wind things up by going back to the authoring tool and looking at what a keyframe might look like. So let's go back over here, and let's just, with reference to this tool, this is the Argentina and Bolivia narrative. And what we have, this is, like I said, a path through. So this is an experience stream here, the one that I'm showing here of a map. So if I double-click on it, bring up the path editor, and use our obligatory waiting while it comes online, each of these things over here are actually those keyframes, logical keyframes. So when it does come up, I'll right-click on it. We can look at the XML, and you'll see it. It has a bunch of map kind of stuff in there. And similarly, the keyframes for pivot, you'd see things like which facets am I doing and so forth. It really is taking a long time. There we are. So let's look at any example here with some time to do with staying. So this keyframe actually is particularly big because it has a whole bunch of those basically polygons, and some of them are visible, some of them are not. But at the top part of it, you'll see kind of the heart of it, which is essentially, for those of you who do computer graphics, it's the viewport to world mapping. How do I map the window on the screen to the three-dimensional coordinates system of the Earth? And so this is an example of a keyframe. And if you go and look at something else, I'm kind of, if I were to open up this image, I'm not going to do it because I don't know what's going to be sitting there waiting for seconds. But basically, when you think about what is the state of viewing a very large image, well, it's pretty much, the small part of the image am I viewing. And so that is going back to my deck. We just looked at sort of how, or rather, a concrete example of a keyframe. And this thing is deliberately very, very abstract. And that it is that kind of abstract approach that has enabled us to use the same system to bring in a very wide, kinds of experiences into this. All right, so let's take a recap. What RIN is, or rather our approach to RIN, is to think of it as a representation. We take this quite seriously, so we really do believe that this is a new kind of media or a meta-media. And then to make it really work, there needs to be an ecosystem of tools and services that can actually do interesting things. What we have shown you is an example of an authoring tool, and then we've shown you, examples of our narratives hosted on a Silverlight-based player. So we are actually very excited by where this is headed. This is a research project, but nevertheless, there's quite a lot of interest. And when you think about it, what we are enabling is this, this notion of these compelling experiences that combine a very strong storyline with, all the emotional engagement of a movie with this notion of being able to interact, but to do that not as a one-off heavy-duty application, but this extensible system, so that if we have this healthy ecosystem, people take this technology and customize it in their own way. You can think about scenarios that have dynamically generated content and so forth. And in fact, we are talking both with product groups as well as a few folks externally about different kinds of verticals. For example, education immediately comes to mind, rich ads, and so on and so forth. So we, as with all the technology from Microsoft Research, are really in the process of defining and advancing the state of the art. I know many people that I have demoed this thing to have always said, when can I get my hands on the tools and so forth. But really, that's something that's work in progress. And just like the spin movies, the sort of taking a step back, the idea of having this research track here on the mixed talk is to give you a sense of what we are thinking, what the next year or two or more might look like. And there's certainly ways to get in touch with us if you're interested, particularly interested in taking these technologies forward. And if you are, like I'm just giving you the link again to our digital narrative site, there's ways to contact us there, as well as I'm sure you can get in touch with us. So thanks again for staying right to the very end. I apologize for the glitches with the authoring tool. I'm not too happy that happened because it makes it just much more compelling when it all works. But this is all real code. So with that, I end. Please fill out the survey form, and thank you very much.